Okay, so continuing with the dynamic modeling process, let's review very fast what is our process. So first of all, when we are trying to model something dynamically, if we should start by analyzing the problem. Then we intend to define the variables that we see in that problem. Once we have defined those variables, we need to identify the relations between the variables. And the first thing that we need to ask ourselves is, are there equations that represent these relations? The relations between these variables that represent the problematic situation that we are analyzing. So if there are equations, we should use them. If not, we should establish them. We should search for more information and make a more profound analysis to establish equations that represent those relations. We can use many methods. One I would recommend is to use statistics to establish, for example, the correlation index between two variables to find out if they have relations or not. If they have, maybe we can establish a linear regression equation that help us identify this relation between those two variables or more, because we can use multivariable linear regression. Once we have all the equations, we can have a dynamic model, and we can program it, and then we can run it and see what we can find. But most of the time, we are going to find out that there are equations already defined for the relations that we are searching for. And maybe the thing that we need to do is to have a very profound analysis and investigation to review as many papers as we can. And always remember, there are lots of information, lots of analysis that other people has done in the past, and that those analyses can help us to establish the things that we are modeling. Never think that you are the first to analyze one problem. There should be many more analysis. And the thing is that we just need to search for those papers, read them, analyze them, and use the information that we need. Okay? Let's think about a simple situation. First of all, let's say that we have an initial inventory of 175 units. We purchase materials in lots in quantities of 100 units every 5 weeks at a cost of $100 per unit. The ordering cost is $500 per order. The warehousing cost is $20 per unit a week. Our sales are constant, and it's of 20 units per week at a price of $150 per unit. If there is not enough material, we need to put a back order that has a cost of $750. So we are analyzing an inventory situation. And at last, we need to define a dynamic model that represents the situations, and we will run it for the next 15 weeks. Okay, so as I was saying earlier, this is an inventory situation, and this is the case that I was mentioning before, that we already have some equations, or we already have some understanding of how an inventory works. And for this purpose, I'm going to use VENSIM, and we will establish a primary model that represents not all of these situations, because I want you to do a much profound analysis and have your own model. I'm just going to give you a little start push, so you can see what we can do with this. Once we have our model ready and running, we are going to answer this question. How much budget are we going to have in 15 weeks according to the situation? So remember, you have to consider all this information to establish your equations according to how an inventory behaves, and then you will try to answer how much budget are we going to have in 15 weeks according to the situation. Okay, so once we are in VENSIM, we should establish the first variables that are very, very easy to identify. The first of those variables is going to be the inventory itself. And the inventory itself, it's a level variable, a variable that accumulates the inventory. So we name this variable as inventory. And the inventory increases with the purchases to our provider, and decreases with the sales to our clients. This is the way an inventory works. And I'm talking a little bit about the economic order quantity. So now we should establish more variables. We need to remember that we buy from our providers 100 units every 5 weeks. So we need to establish these situations in our purchases. So first of all, we need to define two variables, one auxiliary variable that we are going to name purchases, and I'm going to name it purchases table, and you're going to see why in a little bit. And I'm going to use a shadow variable, and this shadow variable will represent the time, because according to the time, we are going to buy more product from our provider or not. In this case, every 5 weeks, we are going to buy product. Okay, and I'm going to relate these two variables to our flow, that it's the purchases. Okay, very good. So now I'm going to establish the equations for these situations, the purchases situation. First of all, open my purchases table variable, and in the type of variable, I'm going to choose lookup, and we are going to define it as a graph. Okay, so now it opens a new window, and here I'm going to establish always when we are analyzing a lookup variable, a variable that we can graph or establish as a table, we need to start with the 0 point, okay, with the 0 point in time. So when the time is 0, we are not going to buy. Time 1, we're not having any purchases. Time 2, we're not having any purchases either. And in time 4, 3, 4, and in time 5, that it's week 5, we're going to buy 100 units. Week 6, nothing. Week 7, nothing. Week 8, nothing. Week 9, and in week 10, we buy again 100 units. Okay, and we need to continue with week 11, 12, 13, 14. And at last, week 15, where we buy another 100 units. So we type OK. We have our variable. Remember, the type is lookup, and we introduce the information as a graph. And once we have introduced that information, we have pairs of data that establish the situation of the table. Okay, so we're okay. We're not going to do anything with the shadow variable called time because it represents the weeks that are passing by. And now we're using the purchases by, and we're going to establish that purchases is the purchases table as a function of time. So what is going to happen is that purchases will be the purchases table for every week, according to the information that we just introduced to the variable. Okay. Now I'm going to define the sales. We have already established that the sales are going to be constant and are going to be of 20 units per week. And for the inventory, as you can remember from the last video, that the equation, it's already there. It's an integration of an equation represented by purchases minus sales, and it's integrating in time for all the whole period. In this case, from time 0, from week 0 through week 15. And we just add the initial value. We can remember that the information that was given to us, it's that we have 175 units of initial inventory. Okay, so this is the main situation, the general inventory analysis. There are lots of other things that we need to analyze, and I'm just going to give you one more tip for the activity, and I'm going to establish one important variable that I identify in this situation, and that's it, and of the inventory difference. And I will establish this concept of inventory difference as the time when inventory, we don't have enough inventory, enough products to make up for the sales. So if there is a time when we have 0 inventory, but we need to sell 20 units, we need to establish that there is a difference, and then we need a backup order. So how can I identify this? I'm going to establish this variable as a function of the inventory. So I'm going to draw an arrow from inventory to inventory difference. And establishing the, I'm going to say that I'm going to use a function, a conditional function, the if then else function. And the condition will be then the next one. I'm going to use the variable inventory. So when the inventory is less than 0, we're going to establish that the value of the inventory will be minus the same variable. So if the variable, if the inventory is negative, I need to establish that the inventory difference is the positive value of that negative value. Okay, because having that a positive value, I can define another variable to use the inventory difference to put a backup order to our provider and get enough product so the inventory doesn't go to zero. So if the inventory is lesser than zero, then I'm going to establish that the value of the inventory difference is going to be minus the inventory, so it is positive. And if not, I'm going to say that the inventory difference is zero. Okay. And I'm going to save this model. I'm going to call it inventory. I'm going to call it dynamic inventory, and I'm going to name it intro. So it's just an intro to the whole model. And now what I'm going to do is I'm going to run this model. Okay, and let's see, first of all, how the inventory behave. So we have, this is the situation. Here is 170. It decreases until it goes down to a value of 75 in this situation. Then it goes up again because I buy new product, and it keeps getting to this 75 value that will be our backup inventory. Okay. But I can also choose, for example, the purchases table, even though I know what the information it will be, just to shake it up. And it represents exactly what we gave to the system. And this is the inventory difference. To see if there were some backup orders, we can assume that they weren't, because we already saw the inventory variable, but let's just see this graph. So the inventory difference was always zero because we always have enough inventory to make up for the sales. Okay, but we have a variable ready when the demand of the product changes, and we can have that situations. So I'm going to leave this video right here. So you can now start modeling your own model and find out if we have enough resources. I just want to give you a quick look of how my model to represent this situation looks like, but I don't want you to use the same variables and try to make the same analysis. Just to know that I have already done it. I'm not asking you to do something I wasn't able to do. So let me show you. Let me see if I can open it from here. I think this is, yeah, this is the model. Okay. So having analyzed this, now it's your time to make your own model, to try to think how to model this situation and answer the question. Okay, so we're going to leave this video right here. Thank you very much.